Hello, I'm Stefan from the Berg support team, and I would like to show you in this video how to customize an ABCL firmware. The ABCL firmware for Berg's devices is a free programmable firmware. That means you have the ABCL firmware with an overlaying application, and this overlaying application you can change according to your requirements. That means you can change or add functionality on the device. On the Berg's homepage in the download section, you can find a couple of such ABCL firmwares. For example, the ABCL zip client firmware, the ABCL IC paging firmware, the ABCL any-to-all firmware, or the ABCL IP intercom firmware. The last one, the ABCL IP intercom firmware, I have already downloaded here. I unzip this now. When you open the unzipped folder, then you will see a couple of subfolders. Some of them are more or less interesting. For example, here we have the Web UI DevKit folder. This Web UI DevKit folder contains the sources of the web content for the ABCL firmware. So here we have the Update Rescue folder. In the Update Rescue folder, you can find firmware, some drivers, and some procedures, some batch files, for example the gen.bat or the serial batch files. And finally, the BCL DevKit folder. In the BCL DevKit folder, you can even some procedures which are important for the development and some subfolders for the BCL applications with the source code of the BCL applications. Here we have the custom one folder, that's a dummy application, and it's the IP intercom firmware. For that reason, we have here an IP intercom folder. When we go into it, then we will see the source code of the web files which the application is using. The application has a homepage and it has a web setup, and that are the source files for that. And it has an IP intercom.bcl. That is the source file for the BCL code. You can open this BCL file with any editor. I'm using Notepad++. And here we are seeing already the source code of the application. When I was looking for a nice demo, then I have found in the manual in section 5.9 the procedure to change the path from the local flash memory to USB file. Per default, the application is using the flash memory for storage of audio files when you will trigger them via command. And in this example, I will change this now to USB, that we can load bigger files to the storage, and this we can trigger then via command. Here's described that in this variable you can store the path where the device should look for the audio files. And per default, as I said, we have here the ROM path, and we have to change that to the USB path. I'm copying now this variable name, going to the source code, searching for this variable name. Here we see in the first line the variable is declared. dim declares the variable, and in the next line we see there is a value assigned to the variable, and this value we have to change. Going back to the manual, copying the value. Now I insert. So here I have insert now the new value. That's all we have to do here. I can save now the file and close this editor. So as next, we have to compile the source code and to pack this into a container which can be loaded to the Barracks device. For that I go one level higher. And that can be done by executing the bcl.batch file. And the folder name has to be used as parameter. So the best way to do this is from the Windows command prompt. For that reason I'm copying the path and opening the Windows command prompt. So cd, and then we are changing to the right directory. And here we are executing now the bcl.batch file with the folder name ipintercom as parameter. The advantage of using this Windows command prompt is that it stays open. And that allows you now to follow up the output and to check for any errors. When we see here the tokenizer is executed. There we see some warnings that we have some not declared variables, but warnings are less important. We see no error. And finally, the tool web2cop is executed. There we see even some warnings for unknown file extensions, but there is no error, so everything was fine. As a result of execution of the bcl.batch file, we have now this ipintercom.cop file. This is the container with the content of the ipintercom subfolder. When we are changing back to this ipintercom subfolder, then we see here a new file was generated. The ipintercom.toc file. This is the executable file which will later run on the Barracks device. It has an updated datecode now and was generated by the bcl.batch file. Even make sure that none file in this subfolder is bigger than 64 kilobyte. Otherwise it will be not used to be packed in the COP container. The source file here is not really required because the source file cannot be interpreted by the device, only the TOC file. For that reason we don't need this file, so it doesn't care that it's bigger than 64K. The last step here is now to execute the application.bat file. I make a double click on it, and as a result we get the application.cop container. This application.cop container contains now this ipintercom.cop and the mimetype.ini, and only such cop containers can be stored on the Barracks device. For that reason I'm copying this now and I'm pasting this into the update rescue folder. So paste, and then I overwrite the existing file. The last step now is to create a new firmware file. Here we have the existing firmware file with the older datecode, and I create now a new firmware file by executing the gen.batch file. So I double click on it, and as you see, it has executed a new or created a new firmware file with the new web content. This new firmware file we can use now on the Barracks device to upload it to the device. I click on upload, on update, then when we are on the update page, I'm selecting the new firmware file and I upload this to the Barracks device. So when it's done, then we get a successful message. Here we are. And now we have to reboot the device. So going back. So the device is already rebooted and the application is still starting. And now the application is started. When you do such BCL developments, then it's always recommended to use a syslog daemon. Here we have a syslog daemon. I'm using the application Megalog, that's freeware from the internet. In the ABCL application, we are often using syslog messages to inform about the status of the device and what the device is doing. And even when we have a syntax error, for example, then the device will send a syslog message. And with such syslog receiver, you can receive these messages and then you know what is going on the device. So I'm starting this syslog daemon now. As next, we have to test our new function. So I have here an Extremer 100 with a connected USB stick, and I have to send now a command via network to the device to trigger the audio file. The command is m equal, then the path it's in the root, and the file name is 2.mp3. Finally, we have to use a termination character, carriage return, or if you want, even line feed. We send this to the configured IP address, port number, to the UDP command port, and when I click now on send, then you should hear the audio file played on the device. So I click on send. Okay, you can hear the audio file is played, and in syslog we even see some messages. We see that the command was received, and here we see the command was played from the USB path. So that means our application is now successfully, and I hope you like this video. If you have questions to the content of the video, then please send an email to support@barracks.com, and thanks for watching.